Jai Hind everyone. Today I am going to start the new topic that is sorting. So first of all, let us understand what is the concept of sorting, why we require sorting. The sorting concept basically arranges our data in a particular order. As we can see that in real world applications, we generally get data in a random order or haphazard manner. But for some processing the data or for some calculations, we require that data to be arranged in a proper order, and for that purpose we required sorting. So C language also provides the facility to sort the random data into particular order, and the default order is the ascending order. So we can maintain our data for various applications in the real world, whether it is the student data, it is marks, it is the roll list, it is the name of the institutes, or we have some other menus. So multiple data we can arrange in the proper order. Now we can see that here we are having some random data. Now this data can be sorted either in ascending order or descending order. So if we are sorting the data in the ascending order, means we are starting from the smallest one to the largest, and in the reverse also we can arrange the data that is in descending order, that is from largest to smallest. So for arranging all these data either in ascending order or descending order, we have various techniques present over here for sorting the data. So today in this lecture we are going to discuss three various techniques, that is bubble sort, selection sort and insertion sort. In PPS also we are having these three sorting techniques in our syllabus. So one by one we are going to discuss all these three. So first is the bubble sort. So bubble sort is the very simplest algorithm which we are having for sorting the data. It works by repeatedly swapping the adjacent elements in the list present, and its average and worst time complexity is quite high because it one by one compare each and every element of the array or the list, and based upon that comparison it will swap the data, it will arrange the data in the particular order. So the time complexity is quite high. Now we just see the process how this bubble sort works. So for example, if I am having an array 5, 1, 4, 2, 8. So as we can see that data is taken in the random order. Now in this the first pass will, how it will work, it will compare first two elements of the list. Now first two elements of the list are 5 and 1. So it will compare these two elements, and here we can see the order is wrong, that is 5 is greater than 1. So in this particular case we will swap these two elements. Rest of the elements of the list will remain same at this point. Now the second step, we simply compare the next two elements present over in the list. So next two elements present in the list is 5 and 4. Means we will just shift position by position for comparing the adjacent elements. So here we compared first and second position. Now we will compare second and third position. Next we will compare third and fourth position, then fourth and fifth position, and so on. So in this way we will compare each and every element, and we will check the order, whether the order is correct or not. As we are arranging the list in ascending order, the order must be correct, means the first element must be smaller as compared to the next element. So next also we will see that when we compare 5 and 4, that is second and third element, the order is wrong, we will swap. Next we will compare third and fourth position, that is 5 and 2, again order is wrong, we will swap. Lastly we compare fourth and fifth element, and here we can see that order is absolutely correct. So here we do not require any kind of swapping, we simply leave the elements as it is. So after complete first pass, what we got is the list of elements, that is 1, 4, 2, 5, 8. Now 8th, that is the last element of the list, is at its correct position after first step. So next after this we will move toward the second pass. Now during the second pass also, second iteration also, the same process will repeat itself, but up till second last element, up till this position. Okay, so again the process will be same. We will compare first two elements, no swapping is required, list will remain as it is. Next two elements, order is wrong, we will swap two elements. Next two elements, no need of swapping. Next two elements, again no need of swapping. Now we have two elements 5 and 8 at its correct position. Now again third pass, the same process will repeat itself. So first two elements, no swapping is required. Next two elements, no swapping is required. Next two, no swapping is required. So in this way we will sort the list of elements. Now let us discuss the algorithm of bubble sort. So when we are processing with the bubble sort, what we are doing, we are performing the overall iterations, that is we are increasing the passes, and side by side inside the pass we are just comparing the two elements, the adjacent elements, and based upon the comparison we are just swapping two elements if required. If order is correct, no swapping is required. If order is incorrect, in that particular case we are swapping two elements. So in this way, we have written here that repeat steps 2 and 3 for 0 to n minus 1, that is we are starting from 0 till n minus 1. So total n steps are required, that is n iterations will be done, and inside those n iterations what we are doing, we are just comparing via the adjacent elements after shifting one step ahead every time. So until we are having j less than equal to n minus I minus 1 elements, we are comparing aj and aj plus 1, and after that if this condition is true, we are interchanging, we are swapping the elements, otherwise we are just simply increasing the jth loop, and after the jth loop is complete, we will increase the ith loop and repeat the process. We will go to the second step or second pass or second iteration. Now how to write this algorithm in a program? So here we are writing the program for the same. In the first step we have declared various variables including array also. Here the size of array is defined as 20, and various other variables are also taken for the loops and other data storage purposes. Next we have asked the user for the size of array, how many elements are there in the list which are needing the sorting. Next, the input data. Here we are taking input in array, that is total list we are accepting from the user using scanf statement. After that the logic starts. From this point to this point, it is the logic part where we are comparing the passes. This is for pass. So for pass 1 we are comparing, this is for the comparison, the adjacent elements we are comparing. So for I is equals to 0, I is less than n, I plus plus, what we are doing, we are going till n minus I minus 1, and there we are comparing first element with the second element, and if this condition is true, we are swapping. This is the condition for swapping that is written in the algorithm for interchanging the aj and aj plus 1. So here we are swapping using the third variable t. Now if this condition fails, all this swapping process will be skipped, otherwise it will be executed. After that we will change the line so that we will get the next step in the next line. After that we are just printing the result, that is output. We are printing the array in whatever manner we are getting. So what is going to be the output of the program? Here we have entered the size of array, that is 6. So total 6 elements are being entered by user, and after sorting we will get this particular array in sorted order. Now what is going to be the time complexity? As we have discussed in the definition part also, the time complexity of bubble sort is very high because it compares each and every element of the array one by one n times. And we have total n steps, and in n steps it is comparing all the elements, adjacent elements, one by one. It is not stopping. So the time complexity is quite high, that is O of n square in case of worst case and theta of n square in average case. So the time complexity of bubble sort is quite high, as we see here also. Next we have the selection sort. As we saw in the bubble sort, the process is quite lengthy and time taking. The selection sort also sorts the element in ascending or descending order the same way, but number of iterations are reduced, because it will work on the sub array, means it will work on the smallest part of the array, or you can say remaining part of the array, not on the complete array as bubble sort was working. So how selection sort works? Suppose we are having this particular array. So in the first pass, what we will compare? We will assume that 64 is the smallest element present within the list. We will assume this, that this particular element is the smallest one. After that, we will look in the rest of the array whether any minimum element is present within the list or not. So when we search, we found that 11 is the minimum element in the list. So as we found minimum element, we just swap the smallest element with the minimum element. Now after swapping, we get this kind of list, that 11 will reach at the first position and 64 will reach at last position, means the first element of the array is at its correct position now. Now next, remaining elements. Now we will assume the same. This is the complete first step. Now in second step, what we will do? We will assume that this 25 is the smallest element. Now again we are assuming the position, the element present on the second position to be the smallest, and the same process in the remaining list we will look for the minimum one. So when we are assuming this as the smallest, and further we are moving and we saw that 12 is the minimum element. So we will swap these two elements. Now 12 is at its correct position. Now the element present on the third position is assumed to be the smallest. Now after that, again the same process, when we assume 25th, that is third position element as the smallest one, we will look for the minimum element in the rest of the list, and we found that 22 is the smallest minimum. So again we will swap these two elements. So what we will get? We will get this list. Now again we take this 25, that is fourth element, as the smallest one, and look for the minimum element in the list. Now we found that no minimum element is present within the list. So we will do not swap anything with this step. Now next, 64 is going to be the minimum element, but there is no list present in the array. No element is present in the array. So the process will stop here only. So we will get the list in sorted order like this. So this is going to be the selection sort, where we are assuming elements on various positions to be the minimum one and looking for the smallest one in the rest of the array, in the sub array. So the process will become little bit easy, a little bit short. Now we will discuss the algorithm for selection sort. So what we are doing, we are just setting minimum to location 0. Location by location we are setting the minimum element, and now we are searching the minimum element in the rest of the list. If we found that minimum, we will swap the location with the minimum, otherwise increment the minimum to the next position, and repeat the process until we will get the sorted list. Now how to program this? So again we have declared various elements or various variables or array. So array is declared here, various elements are being used, we are declared, which are going to be used in the program. Here we are taking the size of array, what is going to be the number of elements present within the list on which sorting is applied. And here we have taken the input, that is the total list on which we are going to apply selection sort. Now it comes for the logic part. So in logic part, what we have written, we have applied I0 till size -1. Why size -1? Because we will not assume last element of the list to be the minimum one, because there is no further sub array present after it. So we will number of steps will reduce by 1. So these are the little changes which are which make it different from the bubble sort, that is total number of steps now are 1 less than the total number of elements. And what we are doing here, we are assuming min p is equals to I, means whatever is the first index is going to be the minimum element. Then after completion of the complete process, when I will increase, minimum will come to the next element, then again to the next element. It will iterate until this loop will false. And after assuming the first element at the 0th position to be the minimum, what we are doing, we are comparing for rest of the array, that is we are starting J loop from I plus 1 till size, till last element, and we are looking for the element which is smallest one or the minimum in the remaining list. So we are comparing A min P is greater than AJ. And min P is what? It is the index value which we have assumed to be the minimum, and AJ is increasing as per this loop, and we are comparing. If this condition is true, min P is updated by the J value, and means min P is now updated by the new index value. And if this condition is false, the min P will remain as it is, what we have assigned here. After that, what the value of min P we get, we just transfer the value using the third variable, that is we will swap the two elements, that is T is equals to AI is equals to A min P is equals to T. That is the swapping part if we found any minimum element in the sub array. Otherwise, this complete portion will be skipped if min P, there is no change in the min P. Next, after that, we just simply print the list, whatever list we are getting. So inside for loop, we are just sampling AI, whatever is the sorted list. So what the output we are going to have, that is we are having the size of array, total elements, and then the output of array, that is in sorted form, that is this. Now what is going to be the time complexity? So again, worst case complexity of selection sort is also O of n square, and average case complexity is theta of n square in this particular case. Next we have insertion sort. So what is insertion sort? Basically, as in bubble sort we compared the adjacent elements. In selection sort, we assumed one by one each and every element to be the minimum and looked for the smallest one in the subarray. As the name suggests, insertion sort is performed by inserting the element at its correct positions. Mean whatever element we want to place, we just place it at its correct position. For example, if I am having the list, you can see then 6, we assume that 6 at its correct position. Now 5 is smaller, we just simply put 5 at its position. Next 3, we simply put 3 before 5 after shifting 6 and 5 one space right. Next we have 1, we simply shift all the elements one place right, and 1 is shifted over at its correct position. Next we have 8, we just compare it with 6, no need of inserting because it at its correct position. Now 7, we just compare it with 8 and we compare it with 6, the correct position is this. Next 2, it is inserted between 1 and 3 like this. All elements are shifted are compared one by one, and when it found its correct position, it is being inserted. Next 4, again each and every element is compared and being shifted one place right, and when we found the correct place, 4 is being inserted at its correct position. So this is insertion sort. So what we are doing here, we are just simply assuming that first element at its correct place, making that element as the base position, position. We compare all other elements present over the other places and compare with that element and insert at its correct position. Here we are not swapping the elements, we are just inserting by the elements by using the concept of inserting of new element in array. What is it that we just shift the elements one place, right? And when we found the space, we just insert that element at that position. So first of all, 12 is assumed to be at its correct position. That is, next we will compare 11. Now 12 and 11. So 11 is stored in some variable. Let us assume we store it in variable x. Now this variable, this data is being stored by us. Now it is being compared by 12. We found that 11 is smaller than 12. So what we will do, we just shift 12 to one place right, and now insert x at its position. Insert x at the position of 12. Now next element is 13. Now there again we will store this element in some variable, so that variable is x. Now we compare it with 12. We found that 12 is smaller than 13. So no need to compare all the elements of the array. We just simply stop the process here only and we just leave the step. Now x is inserted at the same place only. Next we found that is 5. Now we compare 5. So what it will found, 5 is stored in x. Now we compare it with 13. We found 5 is smaller than 13. So we shift 13 one place, right? Now again it is compared with 12. It is smaller than 12. The 12 will come at the place of 13. Again it is compared with 11. 11 will come at the place of 12. Now position at 11 is now empty. So what we will do, we will just simply put x at that place. Same with the 6. So in this way we are going to sort the list using insertion sort. So what we are doing, let us discuss it with the algorithm. For all the elements present over here, that is 1 to n minus 1. Why 1? Because 0th element is assumed to be at its correct position. Now we are assuming key is equals to ai, that is the second element of the array, and j is I minus 1. Now while j is greater than 0 and aj is greater than key, what we will do, we will shift the elements. Aj plus 1 is equals to aj if this condition is true, and update the value of j. After that, when we get the value, we place for the element which is going to be inserted, we simply write aj plus 1 equal to key, means we have inserted that element at the desired position. This is going to be the program. So what we have done, we have written this declaration statement. After that we have taken the size of array. After that we have taken input here, and here is the logic part. What we have done in the logic, that is for I is equals to 1 to n, because first element is assumed to be the correct one. Next t is equals to ai, we are assuming it is the key element, that is the second position. After that we are reducing, then we are comparing the values, and after that we are shifting the elements one place ahead and updating j. After getting the correct place, we are just inserting the data, and after that we are printing the list, that is out. So in this way we will get the output, that is this. And the complexity part, we can see that worst case complexity is O of n square, and average case complexity is also theta of n square for insertion sort also. So I hope the concept of sorting is clear to you all. In the next class, we are going to discuss the next complex topic. Thank you so much.